Well, hello everyone. Welcome to the February 2025 NSS Iowa chapter monthly meeting. I appreciate everyone being here. We have a couple of special guests here tonight that will talk about China's influence and what's happening right now in the space sector. We've had Rod Pyle here for a couple of different times talking about different topics. I think the most recent time, Rod, you were here was when you talked about the book you did for JPL and all the advancements that
Mm.
were made here recently. Rod he wears many hats. One of the hats he wears is the director of communications for the National Space Society. He is also the editor in chief for Ad Astra magazine, and he has written 4,426 books. No, I have no idea, but it's a lot. That was it
20.
20. All right, so it's a lot
It's
of
20.
books. A lot of books on space history and space future, so to speak. And so Rod's a very insightful guy. So he co-authored a piece that which is kind of a op-ed of the Ad Astra magazine that goes out from the NSS on a quarterly basis. And we also have John Cross here tonight to talk with Rod. Rod, I'll let you introduce John because you're more familiar with John than I am.
All right. So Dr. John Cross is our sort of tentpole writer for Ad Astra. He gives me enough articles that he could go on vacation for a year most of the time and I'd still be catching up. But he's a very prolific, extremely detailed, and smart writer with regard to space stuff that most of us don't know quite as much material about. And just so it's said, this piece was written by John. I edited it, but it was really his work. So it did go into Ad Astra. It also, because of John's exemplary efforts, went out to a big chunk of Congress and the Senate and so forth, trying to get some traction. Jerry Griffin was kind enough to help us do that, and so we're hoping that it got read and that people are paying attention. And I might add, it also led, thanks to George Whitesides, to us starting to send Ad Astra to key members of Congress as well. So that's all good stuff. John, did I miss anything about your illustrious career?
Oh, that's pretty much it.
So just so it's said, everybody say nice things to John because if he stops writing for the magazine, it's going to be about a third the length it is now.
Okay.
Well, thank you both for doing this evening. We appreciate it. So, with no further ado, Rod, John, go ahead and take
All
over.
right.
Well, let's start at the beginning here. The op-ed that Rod and I wrote and appeared in Ad Astra and on space.com explores this very issue, and that is, will the next Sputnik moment be made in China? And that's a good question, and the answer is maybe, if current trends persist. So let's move on to the next slide.
Oops, hold on. There we go.
Yeah, yeah, so here's some historical perspective first. In late 1957, the U.S. Navy's Vanguard rocket was primed to launch the world's first artificial satellite, or so everybody in Washington thought. But on October 4th, 1957, the Soviet Union struck first and lobbed a small metal ball into orbit that Moscow radio called Sputnik, which means fellow traveler. Next slide.
And here's what it looked like. Before the TV cameras in the world, here goes Vanguard.
Well, this was Kaputnik.
Oops. Oh, that didn't go well.
No,
And notably, that was 3 weeks after Sputnik had launched, and we pushed the button in panic, and that was the result we got. So not a good
yeah,
day for anybody.
I think we'll go live on television too. But
Yes, it was.
and that Sputnik moment had a profound effect or impact on the space age, significantly escalating the race between the United States and Soviet Union and prompting soul searching in the US and spurring a national effort to promote science and math education. Essentially, it sparked a sense of urgency and alarm that the US was losing its place as the world's preeminent technological leader and causing a major shift in American policy and public perception. A direct line, I think, can be drawn between Sputnik and increased US funding for space research and development, the ultimate expression of which was, of course, the creation of NASA and the Apollo moon landings. Next slide.
If I just add one thing, a lot of people think the Apollo program was wildly supported by the American public, unlike what's going on today with Artemis. And the truth of it is, it was really a geopolitical program more than
Yeah.
anything about science or technology. And the approval numbers are remarkably consistent with today, about 50%.
I was just going to say it was about 50% even back then. So, yeah.
Yeah.
Yeah. The U.S. ultimately won the race to the moon, and the benefits changed America and the world. But the question that faces us today is, can we prevail again? And 67 years after Sputnik, space is the great strategic frontier. Yet the U.S. faces growing competition from countries like China, which is targeting U.S. space assets with space weapons. At the same time, the space economy is exploding as technological advances in reusability, avionics, and artificial intelligence increasingly put lunar resources within reach. Then there's geopolitics. The new lunar push is still seen as a geopolitical statement and a symbol of national prestige. The outcome of this lunar competition will have major ramifications today and well into the future. And next slide. The next Sputnik moment will take place just as it did in the 1950s against the backdrop of great power competition. But this time, the top contenders are the US and China. The US will not only, or the winner will not only claim bragging rights, but will have first dibs on lunar resources, especially at the moon's south pole, where safe sunlit landing sites are scarce. Whoever gets there first will hold the winning hand in setting norms of behavior and rules of governance, which could limit who can access valuable resources for decades to come. And next slide. Is that although the U.S. National Space Policy directed NASA to land the next American man and the first American woman on the moon by 2024, followed by a sustained presence by 2028, both goals remain out of reach. NASA's first crewed lunar landing has slipped repeatedly. Artemis 3, the first planned landing mission, had been slated for late 2025, but was recently postponed to no earlier than mid 2027. That date is supported by a GAO, Government Accountability Office, report stating that Artemis 3 is unlikely to land before 2027 due to the pace of lunar lander and spacesuit development. And interestingly, NASA's own internal analysis tagged an early 2028 landing with a 70% confidence level. In other words, there's a 70% chance that NASA's lunar spacesuit and SpaceX's HLS, Human Landing System, will be ready by that date. However, that also means that there's a 1 in 3 chance that critical technology won't be flight ready till sometime later in 2028 or even 2029. And next slide. Stuff happens, like this is a perfect example of it. Even in the best of circumstances, there will be delays in experimental flight test programs, especially those pushing the envelopes like Starship. So delays are inevitable. And next slide. Yeah, when will the Chinese land put humans on the moon? Statements by Chinese officials and state media confidently predict that taikonauts, their term for an astronaut, will walk on the moon before 2030. China's lunar program designer declared that a crewed landing is entirely possible, quote unquote, by 2030. Indeed, with so much at stake, I think Beijing will take great risks to land before the end of 2029, which is the 80th anniversary of the founding of the People's Republic of China. I believe it's October 1st of the 80th anniversary. So next slide. The deputy director of China's Manned Space Agency, CMSA, has declared that China's human lunar program is advancing on a number of fronts. The assistant to the director of CMSA, this individual right here, Ji Qiming, goes further, telling state television, quote, for now, the development of primary spacecrafts, such as the Long March 10 rocket, Bengao crew spacecraft, Lanyé lander, and spacesuits are finished. If that's accurate, then China actually leads the US for the next crewed landing. Next
And
slide.
interestingly, they've developed this at about the same time that we did the Apollo program. And for some reason, part of it being a lot less money, it's taking us about twice as long this time, just so it's
exactly.
said.
Yep. The contrasting commitments to deadlines is telling. While China single-mindedly pursues a focused and coherent lunar program fortified by a unified political structure, the U.S. lunar program is often swayed by political winds and is struggling to deliver key elements on time. Furthermore, Artemis is architecturally complex and faces regulatory hurdles and delays. The Federal Aviation Administration's protracted and Byzantine process for issuing Starship launch licenses is critical for Starship lunar development is an example. However, a number of U.S. government agencies are involved, including the Environmental Protection Agency and even the Fish and Wildlife Service. Next slide. Well, what is the upshot of all this? That is, the U.S. risks being caught flat-footed once again, as it was in the 1950s. Peter Garretson, co-director, let's go back for a second.
I'm sorry.
No problem. Peter Garretson, co-director of the American Foreign Policy Council's Space Policy Initiative, likens the current situation to the classic fable, The Tortoise and the Hare, with America in the role of overconfident hare. Now we go, next slide. Yeah, the combination of America's delay and China's steady progress raises the specter that the next humans on the moon will not unfurl the stars and stripes. It is entirely possible that the first woman and person of color, NASA's stated priority for our first lunar crew, will speak Mandarin, not English. And if you can see that quote by Thomas, let's go back for a second. That quote by Thomas Zupergen. China and its partners have marched forward, notching one success after another. There's no reason to believe they will not be the first to send a crewed mission to the lunar South Pole. Okay, next slide. Let's consider how ultra-high resolution images and video of Chinese taikonauts on the lunar surface will be portrayed at home and abroad. Apollo's glory days will have far less resonance for most of the Earth's population, who will have no living memory of it. And then here's a quote by Dr. Phil Metzger. He's a co-founder of NASA's Swamp Works. You can pretend that this won't be a national humiliation, he writes, but it will be sold by the CCP as another demonstration of their success and the US's failure. Okay, next slide. The winner of this competition will not only be positioned to reshape global power dynamics, but will have first claim on lunar resources at the moon's south polar region. Besides reaping geopolitical rewards, China could use the prestige garnered by an early human landing to codify regulations by international bodies that would have repercussions for space development. The moon itself has more land area than the continent of Africa, but the supply of prime lunar real estate is limited. The country that returns first will have first access to it. High-level PRC leaders, including senior officials in the government, have called for a cislunar space economic zone to generate a continent's worth of economic activity for China by 2050. This is a singular moment in time. The U.S. should not squander its hard-won technological lead by ceding dominion of cislunar space and the lunar surface to other parties. If we fail to follow through, such a moment may never occur again, and we will have de facto ceded this new era of space life to China. Next slide. And as everybody knows, the landing zones in the coveted South Polar regions are strategically important. From these zones, robots and astronauts can access areas of near constant sunlight for power generation, as well as permanently shadowed regions with potential large reservoirs of valuable resources, including water ice. And as lunar ice deposits are critical for making rocket fuel and breathable option for jumpstarting the lunar economy and other reasons. Okay, next slide. Both the United States and China are targeting some of the same sunlit zones, so landing first is critical. Unfortunately, this lunar contest will take place in a regulatory no man's land with few internationally agreed upon rules and standards of behavior. Beijing, under the guise of landing zones or safety zones or research areas, could mount a lunar land grab with economic and geopolitical consequences. And you can see the quote there by a former NASA administrator, Bill Nelson. We better watch out, he said. It's not beyond the realm of possibility that they, China, say, keep out, we're here, this is our territory. And China has demonstrated territorial behavior on Earth, including in resource-rich areas, and some observers predict the same playbook on the moon. I think it's unwise to assume better behavior at the moon than, say, in the South China Sea, where Beijing has declared administrative control areas, or in the East China Sea, where it has asserted defense identification zones. And again, here's a quote by Dr. Zurbriggen. We do not know, quote, we do not know for certain how China might behave on the lunar surface, but terrestrial conflicts in the South China Sea and China's regular infractions of sovereign airspace give scant rationale for optimism. Okay, next slide. I think we're missing a slide here, but okay.
Oh, sorry.
Okay.
I'd have to dip out to look for it. Can we just move ahead?
Yeah, sure. Well, anyway, let me just back up for 1 second. That slide that's missing here actually was a schematic of the architecture that China plans to use to put astronauts on, or taikonauts on the lunar surface. And it's really a distributed launch architecture. They're going to use Long March 10 or two Long March 10 launch vehicles, which are basically expendable Falcon Heavy class, able to throw about 27 metric tons TLI. The first they will launch their lunar module, what they call Lanye, which means moon embrace. And then they will launch, once that is in lunar orbit, they will launch the crewed vessel Mingzhao, which means dream vessel. Those two will rendezvous and dock in low lunar orbit. Two taikonauts will transfer to the lunar lander and go to the surface, perform surface activities, and then go back to lunar orbit to redock with Mingzhao. Okay, so, and this slide here just gives a slightly more detailed picture of those two vehicles. And let's go to the next slide. Yeah, here's the Langway lunar lander and propulsion stage, which will carry the two taikonauts from lunar orbit to the surface. The total launch mass, interestingly, of the combined Langway lunar lander and propulsion stage approaches 26 metric tons, and that compares with about 16.5 metric tons for Apollo. You see solar arrays provide power. As for propulsion, the lander features four 7,500 Newton main engines and numerous attitude control thrusters. And the specifications for the propulsion stage, I haven't been able to find any details on that. Okay, next slide. And here's a closer look at Mingzhao, the crewed spacecraft. It can carry 6 taikonauts or 3 taikonauts and about 500 kilograms of cargo in the lunar configuration. The propulsion and power module together with the crew module measure nearly 8.5 meters in diameter, about 4.5 meters, and this compares with about 5 meters in diameter for Orion. Its mass of the Mingzhao is anywhere from 21 to 26 metric tons, depending on the configuration. And again, it's no coincidence that the Long March 10 can throw about 27 metric tons of TLI, which is compatible with Mingzhao crew spacecraft mass and the mass of the Langley lunar lander. Okay, next slide. Yeah, here is just a comparison of Orion and the Mingzhao crew capsule. And if you just dig into the details a little bit, the dimensions are roughly the same, and their masses are about the same. So Mingzhao is a significant vehicle. Okay, and next slide. And here's Langway on the surface. According to published documents, it will stay on the surface for a 6-hour stay. with the two taikonauts. It's unclear from sources whether that 6 hour stay on the moon references the lander's total time on the lunar surface or the taikonaut's surface EVA duration. If it's the latter, then the proposed surface mission duration would be comparable to those carried out by Apollo 11 and 12. And clearly that China's lunar architecture is less robust and less capable than Artemis potentially. But I think that distinction will be lost on the global community if China lands first. Okay, next slide. And here you see Meng Zhao and Lan Wei. Oh, I think we're missing another slide. Okay.
Sorry.
Okay, no problem. Here are, here are Lanye, or the suit and the lunar rover that China is designing, and that lunar rover has a striking resemblance to the rover on Apollo. Okay, next slide. Yeah, these are more than just paper spacecraft or CGI spacecraft. An unpiloted prototype for the country's next generation crewed spacecraft was launched in May 2020. And during preparations for reentry, the uncrewed spacecraft performed 7 orbit raising maneuvers to reach a final apogee of about 8,000 kilometers. On reentry, the vehicle executed a skip maneuver employing aerodynamic lift, which extended the reentry time. And this was a technique used in Apollo. So clearly they're running tests to return crew back from lunar return velocity. Next slide. And we mentioned the Long March 10 launch vehicle several times now. As I mentioned before, it's the still in development rocket has roughly the lifting power of an expendable Falcon Heavy. It's a tube booster and central core vehicle. The first core stage and the 2 boosters each have a diameter of about 5 meters and are equipped with 7 kerosene LOX engines for a total of 21 engines at liftoff. And the third stage relies on 3 cryogenic liquid hydrogen and LOX engines. Okay, next slide. And Beijing's lunar ambitions are more tangible than flags and footprints. I mean, the future is not really a race to be first, as important as that is, but rather to exploit space resources and economic growth. The Earth-Moon space has become a new frontier and a new space commanding height for human activities, contend Yang Mingfei, a senior official with China's main space contractor. And he notes that for China now is a key period to seize the opportunity and lead the space industry market. Okay, next slide. And this is just this artist's conception of the International Lunar Research Station. It is a planned lunar base being led by Beijing CNSA, actually with Roscosmos, the Russian space agency, very much a junior partner. And statements from CNSA underline that the project will be open to all interested countries and international partners. ILRS construction missions are expected to begin after completion of the Chang'e 8 mission in 2028. Okay, next slide. And Beijing sees cislunar space as a stepping stone to the rest of the solar system, according to a preliminary blueprint for utilizing space resources. Okay, next slide.
I added this one.
Okay, well, be my guest, Rod.
Well, it's just if we're going to do this, we've been working on a return to the moon off and on since the early 2000s, when it was first announced by George W. Bush as the Constellation program. That got canceled, but key elements of it, including the Orion capsule and the SLS, what became the SLS, marched on. And it's clear that NASA can do it, but the question is, will they be able to? Money is a problem, progress is a problem, prime contractors like Boeing have been a bit of a problem, but it's the moon rocket we have. So abandoning it now would seem to be foolhardy, at least to me and many others I know, including Jerry Griffin and Jim Green, the former chief scientist of NASA, both expressed these sentiments. And the sense of it is we should use the hardware we've been building and finish out the key tasks of SLS, but really start embracing more aggressively the private sector in terms of their achievements. And hopefully Starship can live up to the promise, as it looks like Blue Origin spacecraft will be able to do as well.
Yeah, yeah. To avoid like ceding ground and influence to China and Russia, the incoming or existing, I guess now, Trump administration and Congress should immediately streamline and simplify launch licensing. I mean, elevating the Office of Commercial Space Transportation from the FAA to report directly to the Secretary of Transportation will be a critical first step. And clearing the regulatory and bureaucratic underbrush is the most important and impactful and urgent step lawmakers can take to accelerate Artemis. I don't know if the National Space Council is kaput or what its current status is, but if Vice President Vance, if it does continue and he is in charge of the NSC, he could inject a sense of urgency and energy to get American boots on the ground as soon as possible and permanently inhabit the moon by 2030 through public-private partnerships. And forward-looking space, that's okay. Forward-looking space economic initiatives, including guaranteed purchases of propellant in orbit and subsidized mining of lunar asteroid resources, could be game changers. It's a win-win for everyone. All right, next slide. And this goes back to what you were saying, Rod. And, for the time being, the Space Launch System and the crewed Orion capsule are the only game in town to transport astronauts from LEO to NRHO. However, our prospect of another Sputnik moment should cause America to redouble our efforts and examine top-level goals and architecture for Artemis. And for Zurbriggen, he insists that NASA's recent decisions and reflect an over focus on the Space Launch System. Okay, next slide. And this is a good question. Does SLS Orion have a future? And as we noted, the SLS and Orion are the only vehicles available, or the only available and funded technology to transport astronauts to the lunar neighborhood. To have any chance of returning to the moon before China, I think SLS and Orion are needed for Artemis 2 and Artemis 3. However, both are costly and years behind schedule for a crewed launch. The Government Accountability Office, GAO, released a report in 2023 that describes SLS as unsustainable. And a previous report by NASA's Inspector General suggested that the $2 billion launch cost for each Artemis mission was unrealistic, and the real number was closer to $4.1 billion. Some observers have made statements that predict the chances of SLS surviving are less than 50-50. Some of the biggest backers of SLS are no longer in Congress, and the Trump administration is more open to new space solutions, and Musk, for example. They predict that the SLS will ultimately be replaced because of costs and delays as reusable super heavy lift vehicles like Starship and New Glenn come online. And NASA's acting administrator, Janet Petro, has been urging the White House to allow NASA to fly Artemis 2 and Artemis 3 missions using the initial version of the SLS rocket before the program is canceled. Okay, next slide. And this is just, me spitballing here a little bit, but to some SAR-based architecture to send astronauts to the moon and back. Starship is fully reusable. It has its launch cadence and costs are orders of magnitude less than SLS. Starship HLS is well underway. And of course, Starship HLS is crew rated from the very beginning. It's meant to carry crew. So there's no reason why it couldn't take it from low Earth orbit to the lunar neighborhood. And now to come back would require some air braking, and you need, TPS piles on the vehicle to survive it. So that may limit the mass and so on. But I guess it's theoretically possible. Next slide. And the same thing with Blue Moon. I mean, it's from the very start, it was designed to be crew rated. So there's no reason why it couldn't transport crew from low Earth orbit to the moon. That image on the right side, that's clearly not the cislunar transporter. That's supposed to represent Blue Moon propulsively burning into low Earth orbit. And it's interesting. I don't know if it's just mere coincidence or what, but I think the delta V to go from low lunar orbit to low Earth orbit is about 4,000 meters per second, and the delta V capability of Blue Moon, the crew version, is about 45 to 5,000 meters per second. So, I mean, theoretically, it could burn propulsively back into the Earth orbit. So, okay, next slide. And this is sort of the fast and dirty approach. You know, you could distributed launch architecture where existing vehicles could launch an Orion type vehicle, and it could dock with a upper stage, whether that's the ICPS or Centaur 5. It would be a heck of a ride. I mean, the crew would dock, and they actually would experience negative G's, eyeballs out when on the TLI burn, which is similar to what the astronauts experienced on Gemini 10 and Gemini 11 when they were docked to Agena. So, okay, next slide. And here's sort of the tide of history, or something we call the cultural zeitgeist. We mentioned like potential geopolitical, national security, and economic ramifications, but we should also consider, with history, or as I said, the cultural zeitgeist of China returning humans to the moon first. I mean, the original Sputnik moment triggered an intense American response culminating in the triumph of Apollo 11, but some worry about a reverse Apollo moment. Next slide. If China returns humans to the moon first, the US could suffer the same global loss of face, the same loss of national pride, and a loss of initiative, which could become an existential crisis for Western democracies as China reshapes the future of spaceflight and human civilization in space and on Earth. Next slide. Yeah, resting on past laurels, especially in the high frontier of space, is the surest way to lose that future. So let me close by saying that for a host of reasons, national security, geopolitics, economics, and cultural resonance, being the first to return humans to the moon matters. There is no medal for second place, and the world of history is watching what we do.